Okay, we are continuing here in video 2, solving trig equations. Again, we're going to be solving for the trig function itself. We're solving for the cosine or the sine or the tangent, whatever. And then we're looking those values up using our unit circle. So here in this next example, we may actually need to employ some factoring skills. So this video is going to show several of them that are going to require some algebra skills to do. So first of all, when we look at this next example, cosine x sine x equals 3 cosine x, we need to realize that there's nothing we can do to get that down to only one trig function, which means we need to treat this like a factoring problem. In algebra, when we solved things by factoring, we did so by moving everything to one side of the equation. So we're going to do that here. We are going to subtract 3 cosine x from each side of this equation. What that will do is it will take this equation and put both terms on the same side equal to 0. This allows us to recognize that there is a common factor. Those two terms share cosine of x. So we can factor that cosine of x out of both sides, giving us cosine of x is equal to times sine of x minus 3 equals 0. Now once we've done that, we're looking at a zero product property, which is an algebraic rule that says if I have two things, in this case cosine of x and sine of x minus 3, and they multiply to equal 0, one of them must actually be equal to 0. So we have two different solutions here, two different equations that pop up that we need to solve. Either cosine of x is equal to 0, or sine minus 3 is equal to 0. Now cosine x is equal to 0 only one time on our unit circle. When we go look at the unit circle, the cosine is equal to 0, twice. It happens here at pi over 2 and here at 3 pi over 2. So cosine of x is equal to 0 at those two values, pi over 2 and 3 pi over 2. So that would be our answers for the first part there. Cosine of x is equal to 0 when x is pi over 2 or 3 pi over 2. So those are correct answers. And then for the other equation, we're not quite done solving for sine yet. We move that 3 to the other side, and we get the sine of x equal to 3. Well, 3 is not in the domain. The sine of x is not in the range of sine of x. Remember from our graphing time that we know sine of x's range goes from -1 to +1. It doesn't exist outside of that range, which means this particular thing, x does not exist. Which means that particular one adds no additional solutions. On to the next example. Our solutions to that one would just be pi over 2 and 3 pi over 2. Now the next one here requires us to recognize that cosine to the fourth plus cosine squared minus 2 equals 0. That is essentially, a quadratic function. If we look at that, it's going to be factorable using quadratic methods. Because essentially, if we let u equal cosine squared of x, that is u squared plus u minus 2 equals 0. Our factoring skills should tell us that that factors into u plus 2 and u minus 1. Now since u is cosine squared, that means that this factors into cosine squared x plus 2, cosine squared x minus 1. We are then able to split that up using the zero product property into two separate equations. Cosine squared x plus 2 equals 0, or cosine squared x minus 1 equals 0. In both cases, we would start by solving those individual equations, subtracting 2 from each side of the first and adding 1 to each side of the second. which would give us cosine squared equals -2, and cosine squared x equals +1. When we go to finish solving those by taking the square root, things get kind of interesting. Because our first one, when you take the square root of a negative number, that creates an imaginary number, which means that first one does not have any solutions that are real numbers. The second one, however, does. So when we take the square root of the second one, we get cosine of x equals plus or minus 1, which means we are looking for where the cosine of x is equal to 1 and the cosine of x equals -1. This is side work, it's not involved. Cosine of x is equal to 1 when the angle is 0 radians. Cosine of x is equal to -1 when x is pi radians. What am I talking about? I'm talking about the x coordinate is +1. Well, that happens right here at 0. And at -1 is right there when it's pi. So again, that's just me reading my unit circle. Where is the cosine equal to 1 at x equals 0? Okay. Where is the cosine equal to -1 when x is equal to pi? All right, on to the next page. Another thing we're going to occasionally need to do is we're going to need to use our trig identities. In most cases, when we use our trig identities, what we're using are the Pythagorean identities. So when we look at this first equation on this page, we notice that there are two different trig functions in this explanation. There's a cosine and a sine. Well, the cosine is squared, which means we can turn this entire equation to be in terms of sine if we take the cosine squared out and replace it with its Pythagorean identity equivalent, which is 1 minus sine squared. Okay, everything else in that equation would stay exactly the same. We would just replace cosine squared with 1 minus sine squared. Well, now we can solve this by distributing, which would give us 2 minus 2 sine squared x minus sine x minus 1 equals 0. Then combining like terms, okay, and then we generally do not want to have a lead coefficient that is negative, so then we're going to divide everything by -1, including the 0, because that means that we can do that. That's going to give us 2 sine squared of x plus sine of x minus 1 equals 0. Now again, this is going to require us to recognize factoring. That is essentially the trinomial 2x squared plus x minus 1, which can be factored using the grouping method, sometimes referred to as Michigan M. If we're looking for two numbers that multiply to -2 and add to +1, that's +2 and -1, meaning we would split that middle term, this 1x, we would split that into two other numbers that add to 1 and multiply to -2. Okay, then we would group and factor out greatest common factors. The first set there, we can take out a 2x, which leaves x plus 1. Second set, we take out a -1, which leaves x plus 1, which means my two factors are x plus 1 and 2x minus 1, what's inside the parentheses and what's in front of the parentheses. That tells me, when I look at that pattern, that the green and blue there is just the same exact factoring I would need to do, except instead of x, it would be sine x, which means that this trinomial 2 sine squared x plus sine x minus 1 factors into sine of x plus 1 and 2 sine of x minus 1. Zero factor theorem says that one of those two factors has to actually equal 0. So I split it into two separate equations, and I solve those equations. On the first one, I subtract 1 from each side, which gives me sine of x equals -1. The sine of x is the y-coordinate. The y-coordinate is equal to -1 at only one place, 3 pi over 2 radians. For the other one, I would add 1 to each side, which would give me 2 sine x equals 1. Then I would divide by 2, giving me sine of x is positive 1/2. That happens twice, once in quadrant 1 and again in quadrant 2, where sine is positive. That tells me that x is pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. So again, let's go over to the unit circle real quick so I can explain exactly where those numbers came from. Sine of x equals -1 happens here at 3 pi over 2. And sine of x equals positive 1/2 happens here at pi over 6 and here at 5 pi over 6. So my three solutions are 3 pi over 2, pi over 6, and 5 pi over 6. Okay, next example there, we're looking at sine squared is already isolated, so let's go ahead and replace sine squared with its Pythagorean identity equivalent. So everything else will stay the same. I'm just going to replace sine squared with 1 minus cosine squared. Then I'm going to distribute and move everything to the left side of the equation so that cosine will be positive. Cosine squared will be positive. I don't particularly like writing that underneath the cosine of x because they don't actually combine. I'm just moving that over there. And we're looking at 2 cosine squared x minus cosine of x minus 1 equals 0. Similar factoring to what we saw up above. The only difference is that the signs will be different. That factors into 2 cosine of x plus 1 and cosine of x minus 1. Okay, again, we can see that factoring if we just realize that we can replace cosine of x with an x, which would mean we're looking for numbers that multiply to -2 and add to -1. Well, that's -2x, positive 1x. Bring the other two down, then we group, pull out the greatest common factor, giving us factors of x minus 1 and 2x plus 1. That's where I'm getting the 2 cosine x plus 1 and the cosine x minus 1. Now, each of those would then be set equal to 0, so 2 cosine of x plus 1 is 0, or cosine of x equals 1. Cosine of x is equal to 1. Or actually, I guess first we should solve that first equation for x, cosine x, which gives us cosine of x is -1/2, or cosine of x is equal to 1. Cosine of x is equal to -1/2 in quadrant 2 and in quadrant 3. Okay, so we're looking for x values of -1/2. X values of -1/2 occur here at 2 pi over 3 and here at 4 pi over 3. So 2 pi over 3 and 4 pi over 3 would be my solutions there. 2 pi over 3 and 4 pi over 3. And then cosine of x is equal to 1 in only one place, 0 radians. So we have a total of 3 answers, 2 pi over 3, 4 pi over 3, and 0. Okay, last example for this video, because that's all I'm going to have time to do during my prep today, is this last example here. Again, we're going to look at this and we see cotangent squared and cosecant squared. In both of those cases, we are looking at equations where we can replace the cosecant squared with its trig identity alternative. So we'll be looking at cotangent squared x times cosecant squared is 1 plus cotangent squared x. Okay, plus 2 times, and again, 1 plus cotangent squared x minus cotangent squared x equals 2. Distribute would give us cotangent squared x plus cotangent to the fourth x plus 2 cotangent squared x minus cotangent squared x equals 2. Combine like terms. We only have the 1 cotangent to the fourth. We combine these three. 1 plus 2 minus 1 is 2 cotangent squared x plus 2 equals 2. Now those 2's, those can be subtracted and they go away. We're leaving us with cotangent to the fourth x plus 2 cotangent squared x equals 0. We could then factor out the greatest common factor, which is cotangent squared x. Which means we're looking for cotangent squared equals 0, or cotangent squared x plus 2 equals 0, meaning cotangent squared equals negative 2. Take the square root. We are looking for where cotangent of x equals 0, because the square root of 0 is still 0, or the cotangent of x equals the square root of negative 2. Well, that one doesn't have solutions because that's not a real number, so we can ignore that one. But cotangent is equal to 0. Remember that cotangent is cosine divided by sine, which means cotangent is equal to 0 where cosine is equal to 0. And cosine is equal to 0 in two places, at pi over 2 and 3 pi over 2. So those would be the solutions to cotangent is equal to 0, is where cosine is equal to 0. Because if the top number is 0, it doesn't matter what the bottom number is, 0 divided by anything is still 0. Okay, that does it for that video. Eventually there will be an additional video for the remaining information, but that's 2/3 of the lesson, so that ought to give us a pretty good starting point. Thank you very much for your time and attention.